Welcome to Siding Institute. We're going to do question 11. This is Chemistry 1-1 sheet 1, and I'm going to be very slow answering this kind of question because it confuses many. So the question reads, Iridium has the relative atomic mass of 192.22. If it has two isotopes, Iridium 191 and Iridium 193, calculate the relative atomic abundances of what? Of the two isotopes. So in question 10, we are asked to find the relative atomic mass, and in this question we have been given, I'm using white. Okay, yes, we have been given. So what we have been asked is to find the percentage abundances. We haven't been given in this question. All right. So what we are going to do is this. We are going to do this. We know that the total abundances should be 100%. Okay, should be 100%. That is the total composition of this. All right. So we are going to write the formula, the same formula we are using in the question 10. Okay, we are going to have M1 multiplied by percentage abundance plus M2, we also multiply by the percentage abundance, then we divide by 100. All right, so what we are going to do is that we are going to rate X for M1. Okay, we are going to say X for M1 is going to be, the percentage abundance for M1 is going to be X. Okay, for M1, let the percentage abundance be X. Okay, for M2, what about for M2? The percentage abundance is going to be 100 minus X. I'm going to explain this because the total abundance is what? Is 100. That means if one is X, then our 2 will be 100 minus X, so that we have the value of M2, the percentage abundance of what? Of M2. Let me explain this in other ways. Let's say you are with your friend and you've got 20 apples. Okay, we've got 20 apples. If your friend takes apples, which we can call to be X, he took 12 apples. How many apples have you remained with? You are going to say 20 minus X, so that we may have 20 minus 12, and you are going to get 8 apples. When we add this, we still have a total value of what? Of 20 apples. This is what we are actually doing. This way, our mass 1 is going to be X, and our mass 2 is going to be 100, since this is the total, minus X, so that we may have the percentage abundance of this one. This is how I can explain now the formula which we are going to have next. So our relative atomic mass now is going to be written as L minus 1 times X plus M plus 2 multiplied by now, which is X minus. In this case, we're going to have this. So let me use square brackets here. We're going to have X, 100 minus X. Okay, this is how you find out. You find the formula. Very simple. So what we remain is now to replace the given value. In our case, our M1 is this. Okay, this is our M1. I'm using the white card. Our M1 is this. Okay, it is our first isotope there, 191. Then our M2 is the second isotope of iridium, which is 193 there. Okay, so what we are going to do is to replace the given values. We have been given this to be 192.22 multiplied by our M1 is 191. So we're going to have 191x plus our M2 is 193. We have 100 minus X there. We are dividing by 100. Okay, so what we can do next, what we are going to do next now, we are going out to we can multiply 100 with this. Okay, we can cross multiply. And once we cross multiply, we are going to have 19,222. Okay, 19,000, say 19,222 to be equal, since this is 1, we are just going to have 191x plus, now this we are going to multiply 193 with whatever is in the brackets there. So we are going to have 193 plus 100, we are going to have 19,300. 19,300 minus 193x. Okay, 193x. Then after having 193x, now we can correct the right terms. So we are having 19 minus, this is going to cross to the other side, then we're going to remain with 191 here minus 193x. Okay, with 193x. This is how you go now about it. When you punch this on the calculator, you're going to get, we had 2 here. So the 3 2. So here we must remain with 0.2. Okay. So here we are going to have negative 2x. Here we have x. Alright, now subtracting this into this, we're also going to have negative 38.9. Okay, negative 38.9. So dividing by negative 2, we divide by, actually we have 77 here. It's 77.8. Okay, 77, negative 77.8. Then we divide by negative 2. Alright, so we're going to remain with x is going to be, when we divide this in 2, now that's when we are going to have 38.9. Alright, so our first assumptions, okay, our first assumptions was that the percentage abundance for R, which was 191, was the value of x, which we say to be M1, was x. Okay, that means to say that the percentage abundance of this is 38.9%. This is how you find the percentage abundance of this. Alright, what about the percentage abundance of this isotope, which is 193? We say that the percentage abundance was equal to 100 minus x. Okay, so to solve for the percentage abundance here, we're going to say 100 minus 38.9. So our percentage abundance becomes to be, once you subtract that, you're going to have 190, it's giving me 61.1%. And this makes more sense because when we had this and this, we are going to get 100%, the total abundance. So the percentage abundance we've been asked is this. You specify that this is for 191 and this one is for what? For 193. So this is the end of our today's tutorial. We are continuing answering question, the rest of the question in the next video. So thank you for watching. See you in the next video.